not as bad as it looks.
Really?
It's worse. Let's have a look at what might happen if we take that object from where it was out here beyond the centre point and move it much closer to the mirror, like somewhere between the focal point and the mirror itself. So what are our 3 rules? Who's got the first rule?
Yeah. In parallel out through focus.
In parallel focus.
In parallel out through focus. What's our second rule? In through focus, out parallel. So we're going to line up the focal point with the top of the object. In through focus, out parallel. Who can see a problem? The pink and the blue one are not converging. But they have to converge because when we held that mirror close to your face, as we saw an image. Where are they converging? They don't appear to be converging, but they must be.
At the focal point.
They both go through the focal point. One of them's going in through the focal point, the other one's going out through the focal point. So they converge there.
Is it above the tip of the arrow?
They both touch the object, yeah. That's not where they converge though. Shall we draw on the third ray and see if that gives us a clue? So in and out, straight through centre. So the reflected rays are what we're looking for to converge. The red one, the green one and the blue one. Where do they converge? What are they doing? What are these 3 white rays doing?
Spreading.
Like how far do we have to go this way before they'll touch each other?
They won't.
They're never going to because they're spreading apart, they're diverging. So where do we have to go to make them converge?
Behind.
We have to go to where we're not allowed to be. We have to go into the forbidden zone behind the mirror.
Oh, so that's fake.
And we can see that we don't have to go very far at all behind the mirror to find a place where they converge. And so we can draw our image there. And so the dotty rays reflecting off the real rays, those are called virtual rays. So if we have to dotty off a reflected ray, we call it a virtual ray. If it's a solid ruled one, then it's a real ray. Like the real ray is where the light really goes. The dotted one is showing us where our eye thinks that that red one comes from. So our eye thinks that it's coming from somewhere just behind the mirror. That's where it appears to be coming from. How can we describe that image there?
Virtual image.
It's a virtual image. What else?
It's bigger.
It's bigger. Got a physics word for bigger. It starts with E.
Enlarged.
Enlarged. What else? One more thing.
It's further away from the mirror than the virtual image.
Yeah, which way up is it?
Is it the same way up?
Same way up. We say erect. So if there's not a place where our 3 real rays converge, the solution is always to dotty them back as virtual rays. Where do they appear to come from? And you should find that there's a virtual image formed. When you guys do these, you're going to use a ruler not just to make the lines straight, but also to measure the distances really accurately, because we can use these distances to do calculations about the image. So the distance to the image is the distance from the pole to the image, and the distance to the object, the DO, is the distance from the pole to the object. So just pop those away in your head. DO, distance from the mirror, the pole to the object, and DI, the distance from the pole to the image. Yeah.
Because in math, you're not allowed to like measure the diagrams because it's usually diagrams on such a scale. Like for this, can you use a ruler and like actually measure the diagram and see like what proportions are what?
Yeah, absolutely. These diagrams we are doing to scale.
Sweet.
Yeah.
So,